In this video, we're going to cover what we call rational equations. Rational equations. Rational equations, a very informal definition, is basically equations where your variable x is in the denominator, right? So equations with x in the denominator. And so, of course, we've looked at rational expressions, and rational functions, learning how to add, subtract, multiply, divide, and simplify them. Now that we have that information, we're ready to solve these rational equations. I've given some steps here on how we solve rational equations. First, we're going to find the LCD of all of our rational expressions in the equation. Of course, since we have an equation, we're actually solving now instead of just simplifying. After we find the LCD, we're going to multiply both sides by that LCD, and then we'll simplify. And basically what these three steps allow us to do is to basically clear our fractions. Clear our fractions, right? And then after we clear our fractions, we're ready to solve the resulting equation that'll either be linear or quadratic. And then we can check for what we call extraneous solutions. Now, extraneous solutions are solutions that make our problem undefined, right? So they make equation or part of the equation undefined. The way we're going to find out if a solution that we get from solving this equation right here is extraneous is to substitute into the LCD, right? It's going to be extraneous if that solution makes our LCD equals 0. If it does not make our LCD equal 0, then it is a solution as long as we've done our work completely correctly. Let's look at a couple of examples. In this first example here, I have 2 plus 7x plus 12 over x minus 3 equals 4x plus 21 all over x minus 3. To solve this equation here, we need to first find the LCD, okay? Find the LCD, right? Well, this 2 is over 1, so I have in my denominator a 1, an x minus 3, and an x minus 3. If I look at those, x minus 3 is my denominator. So that's what I'm going to multiply both sides of my equation by. I'm going to take that x minus 3, multiply it on this side, and I'm going to take it and multiply it on this side right here. When I do that, I'm going to have a 2 times x minus 3 plus an x minus 3 times that rational expression there. And then that x minus 3 times this rational expression here. I didn't need to change the order there. It's not a necessary thing. And so you could have written it as 4x plus 21 over x minus 3 times x minus 3. Now that I'm in this case, I'm going to use the distributive property here. When I use my distributive property, I'm going to get a 2x minus 6. On the second term here, the x minus 3's cancel, so we'll be left with just 7x plus 12. And on my right-hand side, the x minus 3's cancel as well, and we're just going to be left with 4x plus 21. What's nice here is that we no longer have any fractions. So we've cleared our fractions now. Also, if you notice, this equation is now linear. All right, this is a linear equation here. Sorry about that. And since it's linear, we need to combine our like terms. So that was where I was heading. The 2x and the 7x are like terms, and this negative 6 and this positive 12 are like terms. They combine to give you a 9x plus 6 equals 4x plus 21. Now that I have this, since it's linear, get all my variable terms on one side, my constant terms on the other. I'm going to pick my left-hand side, so I'll subtract 4x from both sides. I'm going to get a 5x plus 6 equals 21. I'll subtract 6 from both sides. I'll have 5x equals 15. And then I can divide both sides by 5, and I'll have x equals 3. All right. Now this x equals 3 is what I call a possible solution. All right, I need to determine if it's extraneous or not. All right, so in order for me to check that, I'm going to have to substitute x equals 3 into my lowest common denominator. All right, remember in this example, our LCD was x minus 3. And so I'm going to substitute this x minus 3 in for x into my LCD because it represents my denominators, a combination of all my denominators. And if I plug that in, I get 3 minus 3, which is 0. Okay? Well, that's not possible, right? I cannot divide by 0. 0 should not be in my denominator. If it is, I have an undefined solution. All right? All right, undefined equation. So that means x equals 3 is not my solution. It's actually an extraneous solution. And since that was the only possible solution and it was extraneous, then I know that I have no solution. So this is what I would write or give for my answer. No solution. Let's look at another example. We have x plus 3 over the polynomial x squared minus 8x minus 9 equals 6 over the polynomial x squared minus 13x plus 36. Again, what we need to do is we need to find the LCD. In order for us to find the LCD, we have to have our denominators in factored form. What was nice about the last example is that it was already factored. So I'm going to factor this denominator here. A minus 9 and a plus 1 will work. And in this denominator, a minus 9 and a minus 4 will work. Okay? And so if you look, both of these denominators have an x minus 9. My left-hand side has an x plus 1 as a factor. My right-hand side has an x plus 4 as a factor. So as I write my LCD, it is going to be including the x minus 9, x plus 1, and the x minus 4. So that is what I need to multiply both sides of this equation by. And so I'm going to do that. X minus 9 times x plus 1 times x minus 4. All right. On both sides, right? We have to do it on both sides to keep our equation balanced. When we do that, some nice things are going to happen. Here, the x minus 9 and the x plus 1s are going to cancel. And on my right-hand side, the x minus 9s and the x minus 4s are going to cancel. So what we're going to be left with is going to be an x minus 4 times x plus 3 on my left-hand side. And on my right-hand side, I'm going to be left with a 6 times an x plus 1. Of course, I'm going to need to FOIL, use that distributive property to FOIL. I'll get an x squared. When I do the x times 3, I get a 3x. When I do the negative 4 times x, I get a minus 4x. So 3x minus 4x is minus 1x, or just minus x. And negative 4 times 3 is negative 12. Right-hand side, if I distribute, I'm going to get a 6x plus 6. Now that we've simplified both sides of that equation, we can now see that this equation is quadratic. Okay? With quadratic equations, the only way we know how to solve it is by factoring. In order to factor, everything has to be on one side set equal to 0. So I'm going to subtract 6x and 6 from both sides. With that, I'm going to get an x squared minus 7x minus 18 equals 0. Well, to solve that by factoring, we have an x here, a minus 9 and a plus 2 would definitely work for us. And so we now have two things that multiply to give us 0. And so I'm going to set both of them equal to 0 and solve for x. Add 9 to both sides, I get x equals 9. Subtract 2 from both sides, I get x equals negative 2. And so these are our possible solutions. Remember, these are possible. Sorry about that. These are our possible solutions. We need to check them into our LCD. So I'm going to check x equals 9 here, and I'm going to come over here and check x equals negative 2. Now I need to remind myself what my LCD was, because I'm going to use the LCD because it encompasses all of my denominators. Okay, it was x minus 9 times x plus 1 times x minus 4. And so with checking the x equals 9, I'm going to put 9 in for x. I get 9 minus 9 times 9 plus 1 times x minus 1, right? This is a 0. Well, 0 times anything, I don't even care what each of these things are. When I multiply by 0, I'm still going to have 0. That means x equals 9 is not my solution, all right? It was a possible solution, but it is now extraneous, okay? Now let's check x equals negative 2. I'm getting a negative 2 minus 9, negative 2 plus 1, negative 2 minus 4, all right? Are any of these 0? Well, I'm not going to get a 0 out of this first one. I'm not going to get a 0 out of this one, and I'm not going to get a 0 out of this one. I don't care what it equals as long as I know it's not equal to 0. That means it's not extraneous. So if I've done my work up above correct, then x equals negative 2 is a solution. And I'll go ahead and say we did our work correctly. And so my solution set for this problem is negative 2. Okay. So make sure you always check your solutions because those extraneous solutions are possible. Last example we're going to look at with these rational equations here is x plus 3 over x squared plus x minus 12 minus 3 over x squared minus 2x minus 3 equals x plus 7 all over x squared plus 5x plus 4. All right, we want to solve this rational equation here. Again, we've got to find the LCD. Well, in order for us to find the LCD, we've got to factor. So I'm going to have x plus 3 over, well, when we factor this, factors into plus 4 minus 3. These two terms, this second term here, factors into x minus 3 times x plus 1 in the denominator. And on my right-hand side, x plus 4 times x plus 1, okay? Now we got to see what we're going to put in our LCD, right? Well, we have x plus 4 here and an x plus 4 there. It's going in our LCD. We have an x minus 3 here and an x minus 3 here, right? That's going into our LCD. We have an x plus 1 here and an x plus 1 here. That's going into our LCD. All right, so our LCD is going to have 3 terms this time, x plus 4 times x minus 3, 3 factors I should say, x plus 1. And so I'm going to go and I'm going to multiply both sides of this equation by those factors, x plus 4, x minus 3, x plus 1. And I'm going to do the same thing on the right-hand side to keep my equation balanced. All right, when I do that on my left-hand side, I've got to use my distributive property. Now, I'm not going to write this out this time because I don't have enough space, but you're going to see that some things are going to cancel. For instance, if I look here, the x plus 4 and the x minus 3s are going to cancel, and I'm going to be left with x plus 1 times x plus 3. All right, the x plus 1 is here. X plus 3 is on my numerator there, all right? When I distribute to my second term, the x minus 3 and the x plus 1s are going to cancel, and I'm going to be left with the minus 3, which is in my numerator here, and the only thing that didn't cancel was that x plus 4, which is sitting there. On my right-hand side, I will cancel and mark off what I cancel, the x plus 4s and the x plus 1s, and so what we're going to be left with is x plus 7 times x minus 3, okay? And just so we are aware, this is an x here. Let's erase that. And we get this right here. Now I'm going to simplify, because I can't solve it until I see what type of equation I'm going to end up with, right? So I'm going to have an x squared plus 3x plus 1x is 4x with that forward method, those two middle terms. And 1 times 3 is 3. And I'm going to pull the negative with that 3 when I distribute. And I'll get a minus 3x minus 12 equals, let's distribute using our forward method here. we have an x squared minus 3x plus 7x is plus 4x. And 7 times negative 3 is minus 21. All right, and so when we look, we can combine these two like terms here with these two like, and then we can combine these two like terms here. And we're going to end up with the equation x squared plus x minus 9 equals x squared plus 4x minus 21. Okay, this equation here looks to be quadratic. All right, so with a quadratic equation, what we do is we get all of our terms on one side set equal to 0. So I'm going to pick my left-hand side. So I subtract x squared from both sides. But hey, if you look, when you try to subtract x squared from both sides, they're going to cancel. So I'm going to stop there. Although this equation looked to be quadratic, those x squares cancel. It really is a linear equation. All right, anytime you have the same exact thing with the same exact sign on both sides of your equation, they basically cancel. All right, so now I have a linear equation, and so if I want to solve that, I got to get everything on one side set. Actually, my variable terms on one side, my constant terms on the other. So first, I'm going to subtract x from both sides. I get negative 9 equals 3x minus 21. I can add 21 to both sides. I have 3x equals 12. And last but not least, we can divide both sides by 3. We get x equals 4, right? Again, that's a possible solution, right? And so I want to check to make sure it's not an extraneous solution. And so I'm going to scroll back up so I can recall what my LCD was in this example. And it was x plus 4 times x minus 3 times x plus 1. So the only one that had a minus was a 3. So x plus 4 times x minus 3 times x plus 1. All right, plugging in 4 for x, I get 4 plus 4, that's not 0. 4 minus 3, that's not 0. 4 plus 1, that's not 0. So if I multiply three things where none of them is 0, then I know that this thing does not equal 0. And again, I don't really care what it equals as long as it does not equal 0. So that means that this is not an extraneous solution. It is actually my solution, x equals 4. All right, and that concludes the rational equations. Now, I do want to talk about what we call literal equations. That's what we're going to talk about now. A literal equation is an equation that has more than one variable. So it gets a little bit complicated, especially when they contain the variables in your denominator, right? So a literal equation, I'm going to call it an equation that has more than one variable, and they usually have real-world meanings, all right? This equation here is 1 over x plus 4 over y equals 2 over 3. And it is an equation where we want to solve for y, okay? Well, again, as always, we're going to find our LCD. We don't have to factor this time. I have an x in the denominator, a y, and a 3 in the denominator. All of those are different. So they all go into our LCD. So what we need to do is multiply both sides by 3 times x times y, 3xy. When we do that, we have to distribute. And since I have space this time, I'm actually going to write it out. I'm going to have a 3xy times 1 over x plus 3xy times 4 over y equals 3xy times 2/3. Okay. When I distribute, the x's cancel and the y's cancel here. On my right-hand side, the 3's cancel. And so we can just multiply. We have a 3y plus a 12x equals a 2 times x times y. We've gotten rid of our fractions. Remember, we want to solve for y. We're solving for y. Right? I have a y in this term here and a y in this term right here, right? Of course, we're going to want to get our y's at least on the same side. So let's subtract 3y from both sides. So I have a 12x equals 2xy minus 3y. Now, my goal is to solve for y, and I have y in both of these terms on my right-hand side. Now, what I don't want you to try to do is to try to divide both sides by y. All right, that's an x there. Maybe, let me write that a little bit better. Don't try to ever divide by y because you might lose part of your solution. All right, so we're not going to divide both sides by y. What we'll do instead of dividing is to factor. All right, it's a little bit better. I'm going to factor out of y in both of these terms. After I factor out of y, I'm going to be left with a 2x minus 3. Now I have y times this thing, and the opposite of multiplication is division, so I can divide both sides by 2x minus 3. The 2x minus 3's cancel, and we'll have that y equals 12x over 2x minus 3. And this is my solution here. Note, I don't just have, with linear equations, I'm always going to have a variable in there since I always have more than one variable, and I'm only solving for one of them. All right, and this concludes our video on how to solve rational equations.